Good picture.
Yeah, it's pretty good, I'd say.
Right.
What?
Your thing.
Oh.
Oh, it's so blurry.
Column right.
Okay, so there's the first one. Real quick review, that's your linear function, y equals x. Domain, negative infinity to positive infinity, range negative infinity to positive infinity, perfect diagonal going through the origin, slope is 1. Okay, questions on that one? Okay, next one on the list is your quadratic. What would that be? Y equals what? X squared. Okay, y equals x squared. What's the graph of that look like? Parabola. Give me some coordinates.
Negative 1, 1.
Negative 1, 1, 0, 0,
1, 1.
1, 1, 2, 4, negative 2, 4. Okay? Also pay close attention to any y questions I ask you, because those would fall into the Learning Target 3.2 category. Describe the shapes of functions. That would be part of it. Why does this graph have the shape that it does? Well, it'll never go negative because anytime you plug a number in for x and you square it, you'll always get a positive number. And it's a little different than a linear function. A linear function has a consistent rate of change. Okay? When you start squaring numbers, are they going to increase slower or faster? They're going to increase faster, okay, because you're squaring a number, not just going up 1 over 1, adding 1 each time. Yes?
When do you do the little graph thing versus that curve?
I'll talk about that here in a second, okay? That falls into this one. All right, so there's your parabola. Make sure you know how to graph that. When you do graph that yourself, I would probably graph these specific points, okay? Don't just draw some random U, okay, on your graph. Domain. What numbers can you plug in for x and expect to get an answer? Anything, right? Okay? So again, negative infinity to positive infinity. Now, let's say you plugged in those numbers from negative infinity all the way to positive infinity. You plugged every single one of those numbers in. What sort of answers did you get? What numbers did you get for your answers?
0 to infinity.
Everything from 0 on up. You never got a negative number for an answer for y. Did you get 0 for an answer?
Yes.
Yeah, when you plugged in 0. When you plugged in 0, you got 0. So you got 0 and everything above. So therefore your range, because you actually got 0, will be 0 with a bracket, comma, infinity with a parenthesis.
So it's when it's exact.
It's when it exactly hits that value. Yep.
And is the reason that it's not for infinity because infinity is not an exact value?
It's not finite. Correct. Mm-hmm. Yes. Yes. Okay. So y equals x squared. Questions on that? Okay. Next one, cubic. So that will be y equals x to the third, or x cubed. Give me some specific points. Just give me the easy ones.
1, 1.
1, 1.
Negative 1. Negative 1.
Negative 1, negative 1. 0, 0.
2, 8.
2, 8. So I'm going to cheat a little bit and just do this. Y equals x cubed. We probably won't ask you to plot the point 2, 8 and negative 2, negative 8. Okay? But at least get those three and try and draw a nice curve through there. So y equals x cubed. That is your cubic function. Why does that one look like that versus x squared looks like it does?
Because if you have a negative times a negative times a negative, 2 negatives equal a positive, and then another negative will change it back to negative.
Okay, very good. When you plug in a negative number for x, you'll get a negative number for y, because negative times itself 3 times is negative. Okay, is this increasing faster or slower than x squared?
Faster.
Faster, so it's going to be a little bit steeper than the x squared curve, right? Okay, anytime you cube, it's going to grow faster than if you were to square it. Okay, domain. What numbers can you plug in for x and expect to get an answer? anything. Okay, so negative infinity to positive infinity. How about your range?
All.
Same thing, because again, you'll get negative numbers for y all the way down to negative infinity, and you'll hit every other y value all the way up to positive infinity. Questions on that? Everybody got it?